Compound interest. In August 2013, Ali Bank was offering 0.61%. 0.61% in decimal is 0.0061. Interest on his online saving account with interest reinvested daily. What this means is that the interest is compounded daily, or n equals 365. With a compound interest problem, the equation that we're using is P of t equals the initial amount 1 plus the interest rate in decimal, not in percentage but in decimal, divided by n. Raise this quantity in the parentheses to the power n times t. T is the number of years. The initial deposit in this case is A equals 4,000. Find the associated exponential model for the value of a 4,000 deposits after t years. We have everything we need to write this equation, this model. P of t equals 4,000, 1 plus 0.0061 over n is 365, close the parentheses. In the power, it is 365 times t. This equation is the amount after t years, and so we would need to have t as the independent variable. Notice that we replace all of these letters with the given information except for t itself. Assuming that this rate of return continued for 8 years, how much was a deposit 4,000 in August 2013 be worth in August 2021? 2021 minus 2013 is 8, and so in this case, t is 8 years. We are looking for the amount after 8 years. We simply plugged in 8 into t because t is the number of years. 4,000, 1 plus 0.0061 over 365. Close it. Raise to 365 times 8. Be careful when we use a graphing calculator. 365 times 8 have to be entirely in the exponent. If 8 is not in the exponent, then this will not work. If we were to use a graphing calculator and plug it in, we would have approximately 4,200.0395, but we're going to round it to 0.4 cent because this is money. And so after 8 years, if the interest rate is only 0.61%, then we would gain about $200 only. Now, with the current interest rate, some bank would offer us an APR, or the annual percentage rate, of 4%. And this 4% is 0.04. We are done with this problem already. The answer, it was 4,200.04. But assuming that we're doing another problem where the interest rate is 4% instead of 0.61%, we would simply use the equation P of t equals the same deposit amount, 1 plus 0.04 over 365, assuming that the interest is compounded daily, and then we plugged everything in. This will give us 5508.41. The difference in the interest make a huge difference here. And that is why when the interest rate is increased, if we were to borrow money, we end up paying a lot more. If you buy a car, the interest between 2% and 4% will make a big difference.